students, today we are going to see something important repeated questions JE means. Yes, let us go for it. And I would like to thank you for your great support. Yes, let us go for that. The structure of the product P of the following reaction. They have given ortho-methoxy phenol reacts with sodium hydroxide in the presence of carbon dioxide at high pressure, temperature and high pressure with hydronium ion. What is the product? They have given the option A, B, C, D. In that one only might be correct. Other three are wrong. Why they are wrong? Let us go and analyze it. Yes, come on. As you are looking at that question only, phenol reacts with sodium hydroxide in the presence of carbon dioxide at high temperature and pressure with hydronium ion. What is the reaction? It's a Kolb's reaction, familiar naming reaction. Yes, let us go for this. This is Kolb's reaction. Kolb's reaction. Okay, now Kolb's reaction, just I will write it so you will get an idea about that. This is for idea only. Okay, so this is phenol combined with the sodium hydroxide in the presence of carbon dioxide, temperature and pressure, high temperature and high pressure with the hydronium ion, you are getting what it is? Salicylic acid. What do you are getting? Salicylic acid, COOH. Yes, you got it, COOH. Is it visible? So this is what it is. Salicylic acid. Yes. Now, salicylic acid you are getting. Now, what is the complete idea about the reaction? Phenol reacts with sodium hydroxide. You are getting sodium phenoxide. Sodium phenoxide undergoes electrophilic substitution reaction with carbon dioxide, which is very weak. So, sodium phenoxide is more reactive than phenol. Phenol directly it cannot go and react with carbon dioxide. So sodium phenoxide only it will react with carbon dioxide. Why? Phenoxide it is more reactive than phenol. So it undergoes this electrophilic substitution reaction and you are giving the product. Okay, now just to compare this reaction and this reaction, both are like similar only this is ortho-methoxy, no problem at all, same, we can apply this formula only. Yes, so this is, it will not affect anything. So this point OH, that is reacts with sodium hydroxide, sodium phenoxide you will change, so that hydrogen, this is relieve that proton, so you will get sodium phenoxide. This sodium phenoxide reacts with carbon dioxide, then COOH, you will get it. Yes. Now, in that way, which is the correct option? Let us go for that. That means here ortho point only COOH group should be there. Now, let us go for that. Before I could give the answer, I know you, which is the correct answer. You will identify. Yes, is it visible this? So, this too, dicarboxylic acid, it is not at all possible. And this also, ortho and para, no, it is not possible. And this also here, meta position you will not get only first and foremost. Now that finally, yes, there is the answer. This is the correct option. Hope you are clear. We want this option only, no, this point only, COOH, salicylic acid. Hope you remember. Hope you got an idea about this point. Yes, let us go for the next question. The next question, phenol reacts with methyl chloroformate in the presence of sodium hydroxide to form a product A. That A reacts with bromine to form B. Find out A and B. It's very simple, you know. This they have given the option A, B, C and D to product A and B they have given. Yes, let us go for that, and this is also very important questions only I'm providing. Yes, let us go for the first and foremost phenol. This is the first step. Phenol OH reacts with sodium hydroxide. Why directly we are going for sodium hydroxide? Because sodium phenoxide it is more reactive than phenol. Yes, let us go for that point. Yes, here sodium phenoxide we got it. Sodium phenoxide here negative, here positive. So sodium phenoxide that is reacts with what it is. Methyl chloroformate. So methyl chloroformate, I'll write it. This is the first step. Second step, Here ONA, instead of that I just put it O only. O, here this is a negative charge. Combined with the chloro OMe, right? Methyl chloroformate. Methyl chloroformate. Yes. So this is actually carbonyl group. This is what it is actually. Carbonyl group. Carbonyl group is having electron deficient group. This negative charge, it is having actually electron rich. So this carbonyl group is attacked by the, what it is, sodium phenoxide ion, electron rich group. And naturally this is chloro group is attached, this is electron, it is good leaving group, so naturally it has gone away. So you are getting, what is the product here? So here you are getting this point you are getting O, here double bond O, this O, no, double bond, no, this comes down again OMe. Yes, this is the product you are getting. So this is the first product. Okay, this is the first product. Hope you got an idea. This phenoxide ion, it is electron rich, and this carbonyl group is electron deficient. So this carbonyl group is attacked by the phenoxide ion, which is electron rich. Okay, now chloro group, actually it is a good leaving group, very clearly it will go away. Okay, chloro group, it's a very good leaving group. Yes, fine. Okay, now you are getting the first compound, you are getting this one. Yes, this first compound reacts with what it is, bromine. Bromine, right? Yes, compound. This is compound A. I just put it compound A. Okay, now this compound reacts with B. Now in this only we can identify which is the correct option and which is the wrong. Okay, now in that way, yes, this is the correct. Yes, this one as well as this one. First and correct actually, it's correct. But second one, let us see. But whereas C, you are not getting the C option and D option. Why? Because this compound only, we got this compound only. We did not get this compound. Yes, naturally C and D will not be. So in that only. So A and B will check it whether it's correct or not. Okay, now this compound A reacts with bromine. Now what happened in this, which is the functional group? This O, it is a functional group. So the electron density pushed this compound into what it is, para position, due to that resonance. You know what happened? This double bond goes over here, then this double bond goes over here, now this one goes over here. So automatically, anyway, it reacts with bromine, no? So you will get the compound like this. Now note the point, like this the position will be, because due to resonance, so you are getting the para position Br is attached with para position, and O, the same double bond here O, and here Me. I just put it Me over here. Me also you can put it, or else you can put it one bond line that is attached with CH3. That is actually it represents. So this is the compound you are getting. Is it visible? So the CH3 also you can put it, or else you can put it in this way, like one bond line that attached with the CH3. It represents. Hope you are understanding. The first one, what it is, sodium phenoxide ion, which is going to attack the carbonyl group, which is electron deficient, and you are getting this point, right? The compound A. Now, due to this compound, this is actually reacts with bromine, no? So, electron density, it is actually more. So, this is pushed that electron density towards the para position. So, due to that, bromine atom which is attached with the para position. That's all. Now, let us think which is the correct option, which is whether this one or this one. Okay, now here, this is actually here, this para which is not available. Why? Because and this point, yes, it's correct, but this position it's not correct, because this is ortho, means this point only para. Yes, now this point it is correct. First one it is wrong. Second option which is correct, B option, it is correct. Hope you understand why we are getting para position here. Due to that electron density, due to that resonance structure takes place. So resonance, due to that resonance, para position this point which is going to attach. Hope you're clear with the second question. Now let us go for the next question. The next one more important question. An organic compound X on treatment with pyridinium chlorochromate PCC gives a compound Y. That Y reacts with iodine along with alkali sodium hydroxide to form triiodomethane. The compound X and Y we have to identify, and they have given the option ethyl alcohol, acetaldehyde, acetone and acetic acid they have given. Yes, let us go for that. Now what they are asking, X is a compound oxidized with what it is, pyridinium PCC, pyridinium chlorochromate and CH2Cl2. Okay, now it gives compound Y. This it is reacts with what it is, I2 and alkali sodium hydroxide. It gives what it is, CH, what it is, triiodomethane, CHI3. Yes, this is iodoform test. So easily we can come to know what it is X and Y. First and foremost, I would like to mention here, X oxidizes PCC along with CH2Cl2. Definitely, this is a primary alcohol. Why? Because primary alcohol undergoes that oxidation with PCC. You are getting what it is, aldehyde. Aldehyde. This aldehyde only, what it is, reacts with iodine, that is alkali with NaOH. You are getting what it is, iodoform test. Iodoform test. Okay, so here that means X is an alcohol. That is primary alcohol only it is possible. Why? Because primary alcohol gives that aldehyde, whereas secondary alcohol gives what it is, ketone. Secondary alcohol gives ketone. Ketone cannot give the iodoform test, whereas aldehyde can give the iodoform test. So definitely alcohol only is the correct answer. Okay, now here let us go for this CH2O, C2H5OH and CH3CHO and acetone CH3COCH3 and acetic acid. Now in this option, which is the correct answer? As I am telling only, you will come to know which is the correct answer. Yeah, primary alcohol only. I will write that what it is, reaction. So what is that reaction? CH3 CH2OH combined with PCC, that is PCC oxidized with CH2Cl2. You are getting what it is, CH3CHO. Okay, this acetaldehyde undergoes that reaction of I2 and NaOH. You are getting CHI3, that is iodoform test. Okay, hope you understand that CH3CH2OH is nothing, C2H5OH. So option A, it is correct. Option B, why it is not correct? This is the second. Oh, this is the compound Y. This is a compound X. Okay, they are asking the compound X only. So this is the compound Y. Okay, X and Y you find it. Acetone will not be coming. Why? Because alcohol only provides that aldehyde. Secondary alcohol only can give the ketone. Ketone cannot perform the iodoform test. So naturally this won't be there. And acetic acid, of course, it will not come to that dialog box only. Hope you understood very clearly. Now why this option is correct, other three are wrong. Hope you understand. This is very important question. Hope you understand. Primary alcohol only can provide the aldehyde. That aldehyde only can perform the iodoform test. Hope you understand. The next question, heating phenyl methyl ether with hydrogen iodide produces benzene, ethyl chloride, iodobenzene, phenol. It's really interesting question. Let us go for that. Actually, they have given in a different way. Let us think and do it because it's very important question. Yes, let us go further. See what it is: ether, phenyl, methyl, ether. What it is: phenyl, methyl, ether. This is phenyl, methyl, ether. So this is called anisole. Anisole. Right. Okay. Now ether. Anyway, ether reacts with hydrogen iodide. It produces what it is. That's a question. Generally, this is a ether, right? RO R dash combined with hydrogen iodide with the two molecules of hydrogen iodide. Now, iodine, this atom which is going to attach two molecules, no, naturally this also. So, this two hydrogen H2O, you will think in that way, no? That's not correct. Okay, because they have given that clue heating with phenyl methyl ether. So that means this will not be the correct what you are thinking. So that means here, for example, ether reacts with two molecules of hydrogen iodide. So you may get a iodobenzene. In that way, you may think that is not the correct answer as we are coming to this point because they have mentioned high temperature. So that means here will go by the mechanism. Mechanism. So how to go for that mechanism means here I just mentioned here C6H5OCH3. This oxygen has two more, what it is, lone pair of electrons combined with hydrogen iodide. Now what happens? This lone pair of electrons, this electron shift, it will takes place. So you will get oxonium ion, that means protonated anisole. You will get what it is? Protonated anisole. C6H5O, here lone pair, here hydrogen, here positive, because protonated, that hydrogen which is going to attach over here, and CH3 plus I minus you are getting. That is the first step. Step by step we are going. This is the first step. Okay. Now here in this point, this first step I minus. Now we are going for the second step. Now this is what it is: protonated anisole. Right? Okay. Now this I minus. Now I minus C6H5O, here lone pair, here hydrogen, here positive charge, here CH3. That is what I have mentioned here now. Now this I minus, where it will go and attack? This may be going to attack with this carbon. Now what happened here? This, if suppose this minus iodide ion which is going to attack the benzene C6H5 means you will get phenyl carbocation. Phenyl carbocation, which is actually what it is, no stable at all. So naturally, which is more stable only we want. So naturally this will not be happening over here. This will go and attack this methyl group. Why? Because that carbocation will be more stable. Okay. Now another one more thing. This is SN2 mechanism. Right? Okay. That means this I combined with the methyl group. So you will get methyl iodide CH3I. Okay. Now remaining part, what it is? C6H5OH. So what happen if it goes over here? This which is going to attach over here. So C6, so the bond breaks. So C6H5OH. I just put it in the straight line. This is actually a structural formula. This I have written in that stepwise manner. Hope you're clear with that. The first step in the mechanism wise only we have to go. Okay, that means what is the correct answer? Yes, benzene. Can we get that benzene? No, benzene it is not correct. And ethyl chloride, which is not at all in our list only, because there is no ethyl chloride formation. So this is wrong. And iodobenzene, phenol, iodobenzene. Suppose if you think that is the correct answer, that is wrong actually, because they mentioned heating as I mentioned starting only. Yes, this is also wrong. That means which is the correct option? B. It is the correct option. This is phenol. Hope you're clear with it. So anisole reacts with hydrogen iodide. You are getting phenol. Straight answer they have given. Hope you're clear with this. The next question, it's really simple but somewhat Williamsons synthesis. Ethoxy ethane is prepared by passing ethanol over heated alumina, heated ethanol with Ag2O, heating sodium ethoxide with C2H5Br and treating C2H5OH with excess of H2SO4 at 430 to 440 Kelvin. Actually, it's really simple. Let us go for that. Passing ethanol over what it is, passing ethanol over heated alumina. So what happened? Passing ethanol over C2H5OH. So when you pass through that alumina, Al2O3, Al2O3, when you pass through that ethanol, what happened? Ethene, you will get it. What it is? Ethene, CH2, double bond CH2. We want what it is? Ether formation, ethoxy, ethane. So this won't be the correct option. Next, heating ethanol with Ag2O. Heating ethanol with Ag2O. C2H5OH plus Ag2O. Yes, you will get it here. What it is here actually, if you heat, you will get C2H5O C2H5. Yes, we will get. Let us check third one. Heating sodium ethoxide with ethyl bromide. Sodium ethoxide, what it is? C2H5ONA combined with what it is, C2H5Br. C2H5Br. Now what happened? These both will go out. So naturally you will get it. This is C2H5. This is heating, right? C2H5 O C2H5. Yes, this is what it is, ethoxyethane. This is also ethoxyethane. This is also ethoxyethane. In this two option, which is the correct option? Let us check it. The last one, what it is, treating what it is, ethyl alcohol with the excess of H2SO4. H2SO4 only, what it is, releasing water. Okay, that is dehydrating agent, no? So H2O at 430 to 440 degrees Celsius. So C2H5OH combined with H2SO4 heated with 430 to 440 degree Kelvin. So you will get CH2 double bond CH2. Yes. So that what it is, last option also wrong. Okay. First option and last option 100% it is wrong. Why? Because you are getting ethene. Ethene. This is alkene. We want ether only. So these two options wrong. In that B and C, which will be correct? Actually, according to Williamson's synthesis, what is it exactly? Sodium ethoxide combined with the ethyl bromide. This is only that Williamson synthesis. They mentioned that Williamson synthesis. This is also we are getting what it is, ethoxy ethane. We are getting, but they mentioned the clue Williamson synthesis. So that means this option only. So what is that option? C option only it is correct. B option it is wrong. So whenever they are giving the question, two options little bit similar. In that, which is the best option, you have to check and find out. Hope you're clear. And this is also important question. Please note down. I'm providing all the important questions. Hope you understand. The next question, it's so simple but something. Tertiary butyl ether on heating with hot concentrated hydrogen iodide, it gives methyl alcohol with tertiary butyl iodide, methyl iodide with tertiary butyl alcohol, methyl iodide with the tertiary butyl chloride and none of the above. Chloride, there is no point of that chloride, so it is naturally 100% wrong. Okay, now none of the above and A and B. Let us check it. First and foremost, what is the formula? Tertiary butyl ether. C here CH3, here CH3, tertiary butyl, no, CH3 and OCH3, tertiary butyl ether with hydrogen iodide EXs. So on heating, what you will get it? So you will get a simple way, I'll tell you. So tertiary CH3, CH3, CH3 and I plus next one more CH3 OH. This is only the answer. Let us go and find out in the mechanism way. I think that will be more relevant. Yes, this is what it is. This option which is tertiary butyl iodide and methyl alcohol. Yes, the tertiary butyl iodide and methyl alcohol. A option it is correct. And second, B option, this is just a ulta they put it. And chloride, naturally, none of the above, it will not come. So, this is the A only, it is correct. B, C, D, it is wrong. Let us go and find out with the mechanism whether it is correct or not. Let us find out with the mechanism. Okay, mechanism. Okay, so in that mechanism, what we are going the same way, CH3, CH3, CH3. Always mechanism will help us to get the proper and correct answer instead of going for clue. Okay, this is OCH3. So lone pair of electrons will be there. It is reacts with the hydrogen iodide. So when it reacts with the hydrogen iodide, what happened? It reacts with the hydrogen iodide. So naturally, electron shift it will be taking place. So what you will get? Protonated ether. You will get it. What it is? Protonated ether. CH3, CH3. Here CH3. Here O and hydrogen. Here lone pair of electron and CH3 and yes, I minus will be there. Okay, now what happened here? Now this is the step number 1. Now step number 2, what happened? Here only I will mention here. So I minus, which this is actually, if you go away from this will become as a carbocation. So this will become a carbocation. So the carbocation, this I minus will go and attack the carbocation because it's more stable, no? This I minus will go and attack this carbon, tertiary carbon. And here what you will get it, this point here, CH3 OH you will get it, CH3 OH you will get it, methyl alcohol, and here you will get it, just I will put it step 2, here only step 2. Yeah, this is a carbocation and it is more stable. So I minus which is going to attack that carbocation. So what you will get it? CH3, CH3 and CH3 I you will get. So this is T butyl iodide, tertiary butyl iodide and methyl alcohol. Methyl alcohol. Yes, this is the correct option. A, it's the correct option. Hope you understand very clearly. Thanks for watching. This is very simple. You know, diethyl ether combined with carbon monoxide under the condition BF3, it is a Lewis acid with 50 degrees Celsius and 500 atmosphere. What is the product? Okay, X is the product. What is the product? A, it's a ethyl alcohol, ethanoic acid. B, C, ethyl acetate, and D, it is ethyl propionate. Okay, first and foremost, I would like to give the clue with this. See here, usually diethyl ether combined with carbon monoxide, you will get ester only. You know, this is CO and O. From that only we can make out ester formation. Okay, let us go for the C2H5 O C2H5 with carbon monoxide. Under these condition, yes, you will get C2 C2H5, C double bond O, here O. Okay, now here what happened? The CO, no? The CO and O. Yes, C2H5. Okay, now actually what is this? Ester formation only. Ester formation. Okay, so what is the name of this? How can you give the name for it? Okay, like this only, which is a long chain and short chain. Okay, that is ethyl propionate. Propionate. Okay, ester formation. Okay, now here, are you getting ethyl alcohol? Is it possible to get that ethyl alcohol? No, it's not possible to get that. Ethanoic acid, it is acetic acid. Are we getting acetic acid? Not at all. And ethyl acetate, it is not possible as we are coming to the diethyl ether. No, that is also not possible. Whereas here, ethyl propionate, this is the correct option. I hope you can understand all this. When I am writing that formula, I hope you can. The first one, it is ethyl alcohol, C2H5OH. The second one, ethanoic acid, CH3COOH, ethanoic acid, ethyl acetate. Here, third one, ethyl acetate, how to write it? C2H5, C2H5, COO, C double bond O, CH3, ethyl acetate. Okay, ethyl acetate. And fourth option, of course, fourth option only, this is that. Hope you understand. Is it possible to get all this? No, it is. What is the answer? What we are getting? This answer we get. So this is ethyl propionate is the correct. 1, 2, 3 propane. Whereas here 1, 2. Okay, acetate or acetate also we can say, ethanoate also we can say. So these are all wrong option. Hope you understand very clearly. Thanks for watching.